Howdy and good day, fellers. I'm once again out enjoying the comforts of La Casa del Schultz. And so we are using technology to bring the math to you. Now, I do hear and I do listen to the plights of my students. I received a few emails tonight, which to you is last night now, about PO20 and the fact that it is a little bit of a toughie, which it is. It's most likely something new. It's perhaps seeing things in a light where you haven't experienced them mathematically before. And it's all around just, one of the more complicated objectives that we've had so far. And so rather than going on to CO21 today, I'm going to kind of go over the answers to PO20, go over the answers to your homework, and then I'm going to post a quiz in Google Classroom for you to take, and it's going to kind of give me a sense of where folks are at here. So it's not a group project, it's not a team quiz, it's an individual quiz, and feel free to really be honest here. There'll be opportunities for you to kind of write comments and say, I don't understand this type of situation, or this is what's confusing me. Be honest as we go through it here, but also give yourself a chance, okay? That light bulb, once it goes off, you got to be ready for it, and just give it a chance. Give it a chance. So we're going to start kind of down where your homework began here. Okay. What is, I forget which ones we did together. Maybe we did some together. Maybe we didn't. But what is f of 4 when f of x equals 2x plus 12? Okay. Now we talked about this slope-intercept form equation yesterday. Okay, this y equals mx plus b. Basically, any equation that you're going to be able to graph on the corner plane is going to have an x and a y variable because you have an x and a y axis, right? An ordered pair comes from your value for x and your value for y. So what function notation focuses on is these values for x and y. Okay, function notation is a way to kind of ask you, what's x with this given y? Or what's y with this given x? And in this first one, what is f of 4 when f of x equals 2x plus 12? All this f of x here is saying is that this equation, x is a function of y, meaning you're going to plug in x and the output is going to be y. So you can rewrite this as simply y equals 2x plus 12. Those two equations really mean the same thing. F of x is just a fancy way to represent the y variable. So when it says what is f of 4, it's saying what is the output going to be? What is the value of the function going to be when x is 4? Okay, what is the value of the function when x is 4? So then you plug that in. We get, I can write that better, I think. Y equals 2 times 4 plus 12. 2 times 4 is 8, plus 12 is 20. Y equals 20. So the ordered pair that this represents, when x was 4, y is 20. Right? Let's find another one that looks kind of like that here. What is g of 5 when g of x equals negative 3x squared minus 2x? Okay. What is the value of the function when x is 5? Here we have y equals negative 3x squared minus 2x. What is the value of the function when x is 5? That is, what is g of 5? That's what that's asking. So we're going to replace x with 5. Oops, better square that, otherwise it's going to be wrong. Okay. Using order of operations here, we're going to do the exponent first. 5 squared is 25 times negative 3 is negative 75. And then negative 2 times 5, negative 10. Negative 75 minus 10, we get negative 85. So our ordered pair, the input was 5. That's what we put in the equation. And when we got out of it, the output, the y, negative 85. The last one that's kind of like this. What is g of negative 2 when g of x equals negative 3x squared minus 2x. So here we've got a situation, and here's really, where function notation is pretty helpful. Notice that these two functions are the same thing, right? I use the same equation both times. In fact, I do that in the other ones too. Well, the bottom above anyway. But I'm just asking you now, okay, so when x is 5, the output's negative 85. What about when x is negative 2? What is the output then? It's just trying something else. What is y when x is negative 2? That's what this one's asking. So again, we're going to plug in our value for x, this time negative 2. Order of operations, we're going to square first. Negative 2 squared is positive 4. Then positive 4 times negative 3 gives us negative 12. And then over here, negative 2 times negative 2 gives us positive 4. So this negative 12 came from this right here. This positive 4 came from this right there. And negative 12 plus 4 is a negative 8. So when x is negative 2, y is negative 8. Right? Same equation, but just asking what's g of 5, what's g of negative 2, different ways to say what's the value of the function when x is this. The other type of function notation that you'll see literally has that phrase, find x, in it. Okay? And if we remember that f of x is really just a fancy way to write y, you could reread this to literally mean for y equals 2x plus 12, find x when y equals 16. This time I'm giving you the output and say, what are we going to have to put into this equation to get this result? This is the result we want. What are we going to have to put into the equation to get there? Okay? So 16 equals 2x plus 12. And now it's just order of operations to solve this. Basic two-step equation. Subtract 12 from both sides. We get 4 equals 2x. Divide both sides by 2. And we get an x value of 2. So that represents the order pair 2, 16. X is 2, y is 16. Down below, for y equals negative 8x minus 10, find x when y equals 6. Right? Find x when the function equals 6. This is the result. How do we get there? So 6 equals negative 8x minus 10. Again, opposite operations. We're going to add 10 to both sides. 16 equals negative 8x. Divide both sides by negative 8. And we get negative 2. So the order pair, negative 2, 6. Negative 2 is the value, is the input we need to make the function equal 6. I was also told yesterday in an email that I go too fast. So I will pause and slow it down so you can get whatever notes you need. If you need the video pause, just raise your hand, and Mrs. Larson will more than happily do that for you. So the last one here. For the function 12x minus 5, find x when the function equals negative 41. Or for y equals 12x minus 5, find x when y equals negative 41. Okay? So the negative 41 equals 12x minus 5. Another two-step equation, solving for x to get the result we want. Add a 5 to both sides. Negative 36 equals 12x. Divide both sides by 12. And x equals negative 3. So negative 3 is the input needed to get a function value or an output of negative 41. So if you look, I mean, personally, I think the easiest way just to know what I'm looking for is that if it tells me to find x, then they're giving me the value for y, right? They're not going to tell me to find x and then give me the value for x, right? They're having me find x giving me the value for y, giving me the output. Okay, and then for these other ones, what is the value of the function when x is 4? Our input is 4. Input 4 for x. Input 5 for x. Input negative 2. I'm making this really colorful now. For x. And what output do we get? So that's the equation piece of it. The other part of this that you'll see with function notation, and I'll leave the notes up here for a brief moment. I'll check the score of the Vikings game, which is on in the background on my computer right now. 7-6 lead at halftime. Oh boy, here we go. The other spot that you'll see this here is with a graph. Okay, and you're probably used to seeing graphs, with an x-axis and a y-axis, and plotting points and straight lines. But now we've got this t-axis here. What's up with that? This d of t, which remember just means y, right? That function notation, whether it's f of x or g of x or h of x or d of t, it just means y. And the reason why this is a t-axis down here is because it's giving us context. Yes, it's the x-axis, but they're using t instead of x to probably represent time, right? Time in years, okay? So it's the same coordinate plane with an x and a y-axis that you've seen. They're just labeled differently. And so these ordered pairs are all solutions to the functions. Those that seem to cross a corner exactly, but also those that, don't, are just kind of in space here. Any ordered pair that's on that graph is a solution to the function. And then questions 1, 2, and 3 ask you for specific solutions. When it says, what is d of 40? This is saying, what is the value of the function when x is 40? In context here, the reason why they're using d, right, that's the det, and then we already said that t was time. So d of 40, it's like it's saying, what is the det after 40 years, after a time of 40? So what we do, since, written this way, what is d of 40? They're giving us the input and asking for the value of the function. We go to our t-axis and we find 40, right? 40 is right there. We look for the y value or the det value that corresponds with that. When t is 40, the det is at 10, right? Which in context means that 40 years from 1970, because remember here, t is the years since 1970, so this 0 here represents the year 1970. 40 years after that is 2010. So in context, in 2010, the debt was $10 trillion. Okay. The next one, what is d of 25? So this is the same situation as the first one. Now it's saying, oh, okay. 40 years, it was 10 trillion. What about 25 years after 1975? So we're going to do the same thing here. We're going to go to our t, right? It's giving us the input, that x-axis value, which happens to be time here. And we're looking at 25, and we're seeing what y value or what det corresponds with that. 4. So in context, in 1995, which is 1970 plus 25, right? 25 years after, in 1995, the debt was $4 trillion. Okay. Number 3, it says find t when d of t equals 14. Now remember what this is saying. Find t, or time, when y equals 14, or in context, d equals 14. Find the time when the function, which is the det, equals 14. So now we're looking at the d of t value here, right? When does d of t equal 14? When does the debt equal 14 trillion? Well, there's 14 trillion. What year corresponds with that? 45 years since 1970, which is 2015. So the debt was 14 trillion in 2015. Okay? That's how this is used in graphing form. Let's look at the next one here. The function f of x represents the height of a rocket, where x is the time since rocket was launched. I probably should since the rocket was launched, but the time since the rocket was launched, and y is the height of the rocket in feet. So now we are back to labeling x-axis, y-axis. X is the time since the rocket was launched, which makes sense that, this is 0 here, because our graph starts at the point the rocket was launched, which is, time starts when you launch the rocket, so that's at 0. And then 1 second later, it's this high, 2 seconds later, it's that high, 3 seconds later, it's that high, 4 seconds later, it's that high, and finally it lands on the ground a bit after 10 seconds, right? Y is the height of the rocket in feet, so as time increases, as the seconds increase, the height increases as well, right? But then gravity kicks in, and time is still moving forward, but now it's coming back down, and it lands on the ground at y equals 0, because if it lands on the ground, there's no height there, okay? So the fact that it's not launched from 0 probably tells us that this rocket was launched on like a platform, about an 80-foot high platform, okay? Maybe off of a cliff or something like that, right? It was launched already 80 feet in the air. It goes up, goes up, goes up, goes up, goes up. Get out of the way, it's coming down, and it lands at 0. So that's the situation here, okay? And that's what this graph is showing us. Okay, so number 1, what is f of 7? Write your answer in context. So what is the value of the function when the input is 7 seconds later? And you can kind of use logic to understand what they're asking for here. I mean, 7 on the y-axis is right about there. That's kind of hard to look for, hard to see, whereas there's a nice, clear-cut 7 there. The x-axis is kind of by ones, right? But this is asking for, what is f of 7? What is the height of the rocket after 7 seconds? So we look for x, our input of 7. We look for the corresponding height right there, 600 feet. So in context, after 7 seconds, the rocket is 600 feet, or is at 600 feet, I suppose, okay? Number 2, find t, and really, this is kind of a typo. It should be x. I was thinking the above one with t. My bad about that. But find x when f of x equals 300. So in this case, it's saying find the time, or find that x value, that x-axis value, right? Find x when the function, which the function is the height, equals 300. So now we're looking at 300, and at what time or times is the rocket 300 feet in the air? Well, it's 300 feet after 1 second on its way up. It's also 300 feet after 9 seconds on its way back down. So the rocket is at 300 feet, 1 second, and 9 seconds after launch. Looks like a second, 9 seconds. 9 seconds. There are actually 2 answers here, because what goes up must come back down. So it's 300 feet on the way up, and 300 feet again on the way back down. And finally, number 3, how high is the rocket at its highest point how long did it take to get there? You'll learn about this when you talk about parabolas, but this highest point, and this is a parabola here, its highest point is called the vertex point. And how high is that? It's at 700 feet. So how high is the rocket? 700 feet. How long did it take to get there? That's our x-axis. It took 5 seconds to get there. Okay. Uh-oh, Bears just scored. Ooh, Cordero Patterson. He used to play 104 yards. Oh, brother. Here we go. All right. Anyway, so five seconds to get that highest point. So I hope that clarified some things. The quiz in Google Classroom should be posted by now. Please go in, take it. And if there's any issues that you're having, please don't hesitate to ask. We will cover them tomorrow in class. In the meantime, folks, that is how you math. Do not forget to like and subscribe, and have a great day.